Scientists reveal how time travel will be possible. Time travel. Just those two words alone can spark excitement, curiosity, and endless questions. Imagine traveling back to witness the signing of the Declaration of Independence, or fast-forwarding to a world where humans colonize other planets. But here's the real kicker. What if I told you that science is beginning to reveal how time travel could actually work? Yes, you heard that right. While time travel has long been the domain of sci-fi movies and books, scientists have been exploring theories that suggest it could one day become a reality. From Einstein's groundbreaking theories to the mysterious world of quantum mechanics, researchers are inching closer to answering one of humanity's most profound questions. Can we travel through time? Today, we're going to break down the science behind time travel, explore the wildest theories, uncover the challenges, and discuss the potential implications for humanity. So, buckle up and prepare to have your mind blown, because this journey through time starts now. The foundation of time travel. To understand time travel, we first need to dive into the science of space-time. This concept was introduced by Albert Einstein in his theory of general relativity. Einstein showed us that space and time are not separate entities, but are interwoven into a single four-dimensional fabric called space-time. Here's the fascinating part. Massive objects, like planets or black holes, create dents in space-time. Think of space-time as a trampoline. Place a heavy bowling ball in the center, and it creates a dip. Smaller objects, like marbles, will naturally roll toward that dip. Similarly, massive celestial objects bend space-time, causing smaller objects, and even light, to follow curved paths. This bending of space-time also affects time itself. Near massive objects, time slows down, a phenomenon called time dilation. Astronauts aboard the International Space Station experience this on a tiny scale because they're moving at high speeds relative to Earth. In fact, if you spent years living near a black hole, you could technically age slower than someone on Earth. This is one of the first clues that time travel, at least to the future, is possible. Wormholes. A shortcut through time. Now, let's talk about one of the most exciting concepts in time travel, wormholes. A wormhole, also known as an Einstein-Rosen bridge, is essentially a tunnel connecting two different points in space-time. Imagine folding a piece of paper in half and poking a hole through it. That hole is the wormhole, a shortcut through the vast distances of space and time. Wormholes are purely theoretical at this point, but the math behind them checks out. In theory, if we could create or stabilize a wormhole, we could use it to travel between different points in time. But there's a catch. It's not as simple as hopping into a time machine. Wormholes require something called exotic matter, which has negative energy density. This type of matter could theoretically prevent the wormhole from collapsing and allow safe passage through it. Several physicists, including Kip Thorne, have explored the possibility of using wormholes for time travel. Thorne even advised on the movie Interstellar, where wormholes played a significant role. But the big question remains, can we create a stable wormhole? The technology to do so is far beyond our current capabilities, but advancements in quantum physics and particle accelerators might one day bring us closer. Quantum mechanics and time travel. Now, let's dive into the bizarre world of quantum mechanics, where time travel takes on a whole new dimension. Quantum mechanics deals with the behavior of particles at the smallest scales, like atoms and subatomic particles. At this level, the rules of classical physics break down, and strange things happen, things that could make time travel possible. One concept is quantum entanglement, often referred to as a spooky action at a distance. When two particles become entangled, they share a connection regardless of the distance between them. If one particle changes its state, the other instantly reflects that change, even if it's light years away. This phenomenon suggests that information can travel faster than light, challenging our understanding of causality and time. Another theory involves quantum tunneling. In the quantum world, particles can essentially tunnel through barriers that should be impossible to cross. This has led some physicists to speculate whether quantum particles can move backward in time. While this is still speculative, experiments at places like CERN are helping us explore these possibilities. Could we one day harness quantum mechanics to build a time machine? It's not entirely out of the question. Some researchers are already experimenting with quantum computers, which operate on principles that seem to defy traditional notions of time and space. The challenges and paradoxes of time travel. While the science of time travel is exciting, it's also riddled with challenges and paradoxes. One of the most famous is the grandfather paradox. Suppose you travel back in time and accidentally prevent your grandparents from meeting. If they never meet, how could you exist to travel back in time in the first place? Another issue is causality. Time travel could create loops where cause and effect become indistinguishable. Imagine receiving a piece of information from your future self, acting on it, and then passing it back to your past self. Where did the information originate? Some scientists propose that time travel might not alter the timeline we know, but instead create alternate timelines or parallel universes. This idea is supported by the multiverse theory, which suggests there could be infinite versions of reality. In this scenario, changing the past wouldn't affect your original timeline but would create a new one. These paradoxes don't necessarily rule out time travel, but they do raise questions about how it could work without breaking the laws of physics. The future of time travel. So, where does this leave us? While time travel remains theoretical, we're making progress in the fields that could one day make it possible. Advances in quantum computing, black hole research, and our understanding of exotic matter are opening doors we never thought possible. Some scientists believe we could see practical experiments on time manipulation within the next century. Imagine a future where time travel is not just a scientific curiosity, but a tool for exploration, learning, and even survival. However, with great power comes great responsibility. If time travel becomes a reality, it will raise ethical and philosophical questions about how we use it. The road ahead is long, but one thing is certain: humanity's curiosity about time will never stop. Whether it's through wormholes, quantum mechanics, or technologies we can't even imagine yet, the quest to master time will continue to inspire and challenge us. Conclusion. Time travel is one of the greatest mysteries of our universe, a puzzle that challenges the very fabric of reality. While we may not have all the answers yet, the science is clear. Time travel isn't entirely out of reach. With continued research, technological advancements, and an unyielding curiosity, we may one day unlock the secrets of time itself. So, what do you think? Will time travel become a reality in the near future? And, if you could travel through time, where would you go? Let us know in the comments below. Don't forget to like, subscribe, and hit that notification bell for more incredible insights into the world of science and the universe. Until next time, keep dreaming big, because the future is always full of possibilities.